So in this next video, we'll discuss about RF interference. This is one of the major causes of high layer 2 retransmissions happening in a Wi-Fi medium. So in RF interference, there can be two things that can happen. Okay, so let's quickly let me change the bandwidth. Okay, RF interference, it can do two things. One, if in a 2.4 gigahertz spectrum or in a 2.4 gigahertz medium, it can cause a denial of service attack, or it can corrupt a frame. I'll tell you how this is done. Now, if in an RF medium, there is, as we understand that there are different channels available to transmit data, 1 to 11 in 2.4 gigahertz spectrum. We'll just take this example for now. Now, if there is one radio transmitting in one frequency, the other radio cannot transmit in that frequency, right? That's the rule of Wi-Fi in a half duplex medium. There can only be one radio transmitting a frame in a single frequency. So if an AP is working on channel number 1, okay, there can only one radio transmit on channel number 1. If another radio hears anything transmitting on channel number 1, it will defer the transmission. Now, if there is some sort of interference happening on channel number 1, right, then basically it has to be of high amplitude. Let me just remove that. So okay, anyway, yeah, so the channel number 1 transmission is happening and on high amplitude. What this will do is, any other client transmitting on that channel will stop transmitting. If there's a source of interference that is transmitting on channel number 1 at a very high amplitude, the other client on it will stop the transmission. Okay, this is going to cause a denial of service attack in a way, because now if the interference source is transmitting at a very high amplitude, no other radio can transmit at that time. So all the clients will defer the transmissions, and that will block that frequency from any transmissions happening, right? Which is called, in a way, a denial of service attack. The second thing it can do is, it can corrupt a frame. Okay, now corruption of frame is very common due to RF interference, which will again cause very high L2 retransmissions, right? Now, I just want to highlight one more point in this DOS. When a client tries to transmit information or transmit a frame, it basically hears during clear channel assessment that there is some other energy on the same channel and I need to stop my transmission. So this is how the client near the AP figures out that there is another client or another source of interference or whatever, something is transmitting in that frequency at that time. It does it through clear channel assessment, which all the clients do before transmission of data. Okay, anyway, if the frames here, so coming back to this, if the frames are corrupted, we can expect a very high retransmission rate, right? Now, there are several different types of interference. I'm going to talk about that also, but we're going to be focusing on two of them in this course. One is narrowband. It's narrowband interference. Okay, again, taking an example of a 2.4 gigahertz spectrum, we know that there are 11 channels in this, 11 channels, and 1, 6 and 11 are the channels used by the APs to transmit data, because they are the non-overlapping channels. Again, more details are available in the fundamental course, so please go ahead and watch those videos as well. So yeah, 1, 6, 11 are channels used in 2.4 gigahertz spectrum. Now, narrowband interference basically is when the RF energy is focused on one particular channel. Okay, when the RF energy is focused on one particular channel of, let's say, 2.4 channel number, let me just use the eraser and remove this for now. Okay, coming back to the pen, 1 second. Okay, yeah, good. So narrowband signals can disrupt one or several frequency channels. Okay, so now in 2.4 the frequency range starts from 2.401 to 2.473. This is the 72 megahertz band that we get to transmit data. Channel number 11 channels that it has. In Europe, this is pretty much for US. In Europe, this goes beyond, and then we can have 14 channels also in Europe, 1 to 14. But let's say I block, there's a source of interference that is blocking only channel number 1 or 2 or 3 or 4 or 5 or 6 or all of them. Okay, like 1 and 3 and 5. So there can be one particular frequency jam, or there can be multiple channels which can also be jammed. So that is called a narrow band interference. So in this particular frequency only, the RF source of interference will be transmitting data with very, very high amplitude. Okay, now as a result, the client obviously cannot transmit data. That is the reason why since it is only on a single channel, that's called, or single frequency, or a bunch of frequencies, it's called narrow band interference. Okay, the only way, or the only way to figure out as to where the source is to use something called a spectrum analyzer. Okay, otherwise it's very difficult to figure out what could be the source of this interference. Nowadays the jammers are so advanced that I can basically sit in one building and jam the frequency of the clients or of the access points in another building. I can focus my energy of the RF jammer on that building, and that entire spectrum can be jammed, or it could be a narrow band interference source also, which can jam a few frequencies. So the only way to figure out is to use a spectrum analyzer and check which frequency or which channel is seeing high interference source, and basically do a redesign of your channels. Because if anyway in 1611, or let's say take an example of 5 gigahertz, we have 36, 40, 44, 48, 52, all these channels are available, for example, and only if channel number 40 is jammed, I can figure that out from a spectrum analyzer. I can just quickly check, okay, channel number 40 is jammed, or a narrow band interference source is on channel number 40. I can do a redesign of the channel schema, and next time I can use 36, 44, 48 and 52, till the time I am able to remove that source physically from my network, the source of interference. And that's kind of a solution to implement if you have a narrow band interference. The other solution is definitely to go and remove the interference source completely from the network, right? Now the second interference type is a wide band interference. Okay, now as the name suggests, it basically does something similar to narrow band, but instead of jamming one particular frequency, it jams the entire range of frequency. So in 2.4 gigahertz, for example, it will jam the entire 72 megahertz of spectrum. So 2.401, where it starts, goes all the way to 2.473, that is 72 megahertz. A wide band interference source will jam the entire frequency, causing a denial of service attack, right? So nobody in that frequency space can transmit data. Now you either move your network to 5 gigahertz, okay, or just you have to find the source physically. You have to use a spectrum analyzer and figure out where the source is, and simply manually remove it. Manually remove the source of interference. These are the only things you can do. Wideband interference is a little more drastic. It has an adverse effect on the network a little more than narrowband, because in narrowband you have the option to move to other frequencies in the same channel, in the same frequency range, 2.4 gigahertz or 5 gigahertz. But in a wideband interference source, the entire block of frequency is blocked, which will really you'll have to go and find the source, or move the entire network onto a different radio altogether. So that's how the layer 2 retransmissions increase, or there's a denial of service attack that you can see and experience in the network, right? Anyway, in the next video we will talk about multipath. So see you in the next video. Thank you.